Okay, it is recording. All right. One second. Yep. Okay, cool. Okay, good morning, everyone. Welcome everyone to Fit 5136 again. Today is the week 7, which we'll talk about the test-driven development, unit testing, and the code coverage. Okay, so before we begin, I would like to acknowledge the Aboriginal people at the our as the traditional owners of this land, and we pay our respect to elder past and present. Okay. Yep. So this is the unit learning outcome for Fit 5136. And I just want to remind again that this lecture is about the unit learning outcome number 4 here, which the goal of this lecture is to make sure that every student, everyone can implement and execute software testing strategies to ensure the reliability and the functionality correctness of the developed software. Okay. And today, because of this unit learning outcome, it is also aligned with the lecture content this week as well, which is about test-driven development, unit testing, and the code coverage. And the purpose of learning this one is that everyone need to use the knowledge from this lecture for the assessment for, okay? And this is the high-level unit structure that I have presented to you since the week 1 already. For the assessment for, just want to remind everyone again, we will talk about the software quality and testing. It is the individual assessment, which is weighted 30%, and everyone will work on the ED step. Okay, so yeah, from the for the unit content, week 7, 8, 9, 10, it is aligned with the assessment for. Okay, and this is what I have told you before as well, that yeah, for the assessment for, we will have basically 3 tasks, that 2 tasks about the unit testing in ED STEM, which is with 10% and the 15%, and the third one will be the ethics quiz. Okay, and everything is due by week 14. So I understand that right now everyone is working towards the assessment for, which is due this week, and probably next week you will work on the assessment 3, but the knowledge that you learn from this week is also applicable to your assessment 3 and assessment 4 as well. Okay, and this is just a summary. In the past few weeks, we run the FLUG quiz, and this is just some of the feedback that we have got from the student. Most of the students found that the lecture content right now is at a good pace, and the FLUG quiz is actually help everyone in the help everyone do the active participation and active engagement as well. And I think the key purpose of doing the FLUG quiz here, we don't do any mark, but the real goal is that we want to make sure that everyone understand the concept or the content correctly, right? When we do the FLUG quiz, if you give the wrong answers, then we can clarify what went wrong, what is the misconception, that kind of thing, okay? So I found that this learning technique is really helpful for everyone, okay? And today, we're gonna do the FLUG quiz again, okay? All right, this is the high level again. As part of the Agile Scrum project management, we structure the unit to follow the Agile project management. And in the first few weeks, we talk about the introduction to software engineering. And then as part of the assessment one, every student have elicited the requirement already. For the assessment 2, you have done the design. And for the assessment 3, you will work on the project management, develop the piece of software, which is aligned with the module 4, module 5 that we are going to talk about here as well. But once you develop the software, right, how can you ensure that the software is functionally correct? How do you ensure that every component in the piece of software is actually work as we expected or aligned with the requirement, right? So the key point of the one of the technique to evaluate the functionality correctness is to do the unit testing or software testing. Okay, so that's why we really need the software testing today. Okay. Yes, no, sorry, not yesterday. Last week, we talked about the importance of the software quality and the testing already. Why the software quality is so important, the bugs are so expensive, right? And then we already covered different software testing technique, right? Like the waterfall style software testing approach or the agile testing approach. But today we're gonna delve down into the fine grain level, the real practice. How do we develop unit testing to test your software? Okay. So by the end of this session, right, by the end of this lecture, I'm pretty sure that you will be able to understand the concepts of the test-driven development, what is the unit testing, and we will do the hands-on demo on how to write the unit testing in Java and Python as well. I understand that different students have different programming language background. They have some of the students learn Java before, some of the students learn Python before. So in this lecture, I just want to make sure that everyone can leverage the knowledge that you have before. So I will provide a tutorial on how to write the unit testing for both programming languages. All right. And then after that, right, I already implement the EDSTEM exercise as well. So you can practice yourself, do some exercise, write the unit testing to make sure that your code is correct and you can write the test case as well. Okay. In general, right, what is a test-driven software development? I think the wording is quite straightforward. So test-driven, it means that when we develop the piece of software, everything is driven by the test case. Okay, so the key point here is that we want to write the test case first before we write the code, which is quite difficult in real-world scenarios. You know why? Because when we elicit the requirement, you get the requirement. Basically, before you write the code, you need to write the test case first. And what happened is that you need to deeply understand the requirement, right? So you can develop the test case correctly. Let's say you want to implement a calculator application, okay? Calculator application. There's a different operation there, like addition, subtraction, that kind of thing. At least you should have some mathematics background that addition is will work like that. 1 + 1 = 2. Once you understand the requirement, then you can develop the test case correctly. For example, 1 + 1 should equal 2. The expected output should be 2 rather than 3 or 4, something like that. Okay. Yep. So based on the workflow on the right hand side here, this is the high level workflow. First, the first thing that you need to do is to add a test case. Okay. Once you develop the test case, then you execute the test case. Normally, when you execute the test case, you haven't write the code anything. So the test case will be failed anyway. So once it is failed, then you make change to the code. Make sure you write the code until it is passed, that kind of thing. Okay. Execute the test again. Once it is passed, then you can add a new test case, that kind of thing. Okay. So the key point here is that you want to write the test case that is failed, and then you write the code to make it pass. Okay. That's the key points of the test-driven development. All right. Yep. And this is just some of the history, right? Ken Beck is actually one of the pioneer of the test-driven development. So what they said is that they said the test first code tends to be more cohesive and less coupled than the code in which testing is not a part of the intimate coding cycle. Okay. So if you cannot write a test for what you are about to code, then you should not even be thinking about the coding. That means when you want to implement something, you should deeply understand the requirement before. Okay. Otherwise, you cannot do any coding. You cannot even design the test case anyway. But the key purpose of designing the test case before because we want to know that what is the expected behavior of that method or that class or that Java file or Python file, that kind of thing, you know? So, okay, in summary, this is the loop, the cycle, the workflow here. Write a failing test, make the test pass, and then you refactor the code. This is only 3 steps, nothing more than that, all right? So let's, I just want to give you an example. Let's imagine that we would like to develop a method addition to the calculator class, okay? We already know the requirement, okay? Addition, 1 + 1 = 2, nothing more than that. We just use the summation, the addition operation. That means the expected test case, the test case that we want to decide here is that 2 plus 2 should equal 4, 1 plus 1 should equal 2. Okay, so once we write the test case, then we can write the addition method, right? And then we would test it, execute the test case to make sure to check whether that test case is passed or not, or failed. Yep. The benefits of the test-driven development here is that you get the instant feedback immediately, right? When you write the test case, you write the code. If the test case is failed, it means that your code that is written may be buggy or maybe functionally incorrect or that kind of thing. So you get the instant feedback immediately. If not, if you don't have the test case, you only write the code, right? You may have no idea whether the code is correct or not. Okay. And then it is another benefit of doing the test-driven development is that it gives you a better development practices as well, because this development practice encourage you to decompose the bigger problems into the smallest tasks. Let's say if someone asks you to develop a calculator method, right? I think this is too big because one calculator it has so many operations, and because when you decompose the bigger class like the calculator app into a smaller component here, that's what into a smaller unit, right? Then you can test each individual component easily. So this is a good practice to break things, break the complex or large component into a smaller and manageable component as well. So this is a very good practice and that I highly encourage everyone to do. Okay. Yep. And another thing is that by focusing on writing only the code necessary to pass the test, the designs can be cleaner and clearer than the other approach as well. Because you know what is the expected behavior of the method, right? So you can decide the code better, yeah, because you know what is the end goal anyway. Okay. And it also provides a better quality assurance to the overall quality of the software system as well. Okay, TDD practices write programmer to write the code that is automatically testable. Sometimes you write the code that is really complex with lots of for loop than while loop, right? And the code is really long. It's prone to be more buggy than the other way around. So that's why when you know this is only the expected behavior, you can decide the test case, then you know what to code. Yeah. So that's so TDD also gives you a better quality as well of the code, okay, and less rework effort as well, because we already try to write the code to pass the test case. All right. However, there are some limitations to the test-driven development as well. For example, it is quite counterproductive and it is hard to learn, right? Let's imagine that addition function is an easy code, easy method, right, to code. But if you think about the real world scenarios, let's say you want to develop a software, what would be a good example? Like think about the subway, okay, subway shop. You have so many combinations, right? There are different types of the bread. There are different types of the garnish, vegetable, meat, or whatsoever options, right? And then if you think about the Subway online order system, so that's a very complex system, and it becomes a little bit hard to write the test case early on before doing the code. Okay, this is some limitation anyway. Okay, and yeah, because of the complex requirements, sometimes writing the test case upfront is quite time consuming. So it may impact the developer's productivity as well. That's one of the key limitation. Okay. So anyway, but let's say for this unit, right, we're gonna do we assume that we're gonna use the TDD for the assessment 4. Okay. Everyone should understand the requirement first. Otherwise, you cannot implement the code correctly. Okay. And to implement the test case at the beginning, we're gonna focus on the unit testing. We have cover the topics about the 4 levels of the software testing before. There are 4 levels, right? Starting from the bottom level, the unit testing, the system level testing, integration testing, acceptance testing, that kind of thing. So when we talk about the unit testing, it means that we're gonna test the smallest parts of the software system. And I would say that in this case is the method, okay? Method in the Python file or the Java file. And the purpose of doing the unit testing is that we want to verify whether that method is actually functionally correct or not based on the requirement that we that we elicit from the customer, okay? In your assessment, we are in this semester, we talk about the Monash Merchant online shopping system, where customer can add the product, delete the product, that kind of thing. So each of the class, Java class that you have, you may have like the product addition, that kind of thing, right? So this is like a test case scenarios that you need to develop to ensure that that particular method in your class is actually correct, okay? So the key goal, nothing more than that. We just want to verify that whether the method is functionally correct or not, okay? And if not correct, then you can fix it immediately, all right? And the figure on the right side here is just want to give you a bigger idea, right? A high-level overview of where the unit test is, okay? Normally, right now, we use the GitHub or the GitLab, which is like a pool-based software development practices. Developers or software engineers here, we already start the code development here. They need to write the unit test. They execute the test case. If it is failed, then it go back to the developers again, right? So they need to write the test case, write the code to make it pass. Once it is passed, then they can create a pull request or a new code contribution, right? So the pull request will be for each of the pull requests, the CI/CD server will automatically execute the test cases to make sure that whether the code contribution that you submit is actually correct or not, or it breaks the other part of the software system or not, right? If not, then your code contribution or your pull request will be automatically merged to the main branch of the GitHub repository, all right? Okay, this is a typical software development workflow that that is used nowadays at Google, Microsoft, everywhere. Yeah. Okay. Yep. As I mentioned to you before, yeah, the purpose of the unit testing is to make sure that the functionality of each of the component is correct, right? But it is different to the other levels of the software testing. I tell you before that the unit testing, that's how we test the small component. Let's think about the car here, right? Unit testing, it means that, one car, it consists of many wheels, the steering wheels, that kind of thing, okay? When we talk about the unit testing, it means that we want to check whether the wheels work correctly or not. And the steering wheel also works correctly or not. But it doesn't mean that the steering wheels can control the wheels, okay? To test whether the steering wheels can control the wheels or not, that's the integration test for the car. Okay, let's think about the self-driving car system. And when we want to do the system testing, system level testing, it means that we can driving down the highway with the air condition on, working, that kind of thing. You know, it's like everything combines together. That's a system level testing. Okay. Yep. So why do we need to do the unit testing, right? Why don't we just test the whole car? Okay, easy. Why do we need to test like a small individual component here? The purpose here is that we want to reduce the potential errors when we integrating everything together, okay? Let's say you build a car, but the car cannot be drive, okay? You cannot drive the car. But you don't know where the bugs are in the self-driving car system, okay? So that's why you need to test every small component in the self-driving car system to make sure that where the bugs are, right? Otherwise, you have no idea. You may end up like another 3 years to find out where the bug is, okay? Okay, but when we talk about the unit testing or the test case, okay, we need to understand what does it mean by the test case here, okay? Last week we cover about the how to design the test case already. We talk about the requirement traceability matrix, right? We have the requirement, we have the test case ID. We want to do the mapping table, whether this test ID belongs to which requirement, that kind of thing, okay? So this is a high level information of the test case. Normally, each of the test case, it should have a unique ID, test ID number 1, number 2, number 3. It should describe what is the purpose of this test case, okay? What it is going to test here, which method, and what is that scenario, okay? And whether there is a assumption or the preconditions or not, this is optional. But the most important thing is that you need to have the test input, right? Let's say the calculator app, it takes only 2 integer numbers. Probably the test input could be a equal to 2, b equal to 2. And then the expected output here, 2 plus 2 should equal 4, right? So the expected output should be 4. And once you execute the test case, you will get what is the actual output. So if the actual output is 4, it means that the test case is passed because the actual output is the same as the expected output, right? But if not, it means that the test case is failed. The concept is very easy. Okay. Any questions so far about the test case design here? I hope no. Okay. So I'm going to move on to the next step, right? And then when we write the test case, normally we need to write the assertion statement in the Java. Okay, these are an examples of the assert statement in the Java. For example, the first one, when we I would say it is the frequently used one, the commonly used one. Assert equals. It means that we want to assert whether the expected outcome here, the first argument here, is equal or the same as the actual outcome or not. Okay, that's the key concept. Let's start with only the first one, only the assert equal. So if you go back to here, right? Where is that? I should have a few more. Okay. Anyway, this is a different types of the assert statement. Okay, but then the next step is that when we understand the requirement that is given by the end users or the customer, right? We need to think about what should be tested. Okay. I give you 5 high-level categories here. What should be tested? Okay. The first one is about the positive testing. Positive case, I would say. It means that you just want to verify whether the function behave correctly or not. Let's say addition. Okay. 1 plus 1 equal 2. This is a positive test case because this is a test case for what we expect. Okay. But in addition to the positive test cases, we also should test the negative scenarios as well. Okay, it means that the system should also handle the invalid input. Okay, let's say addition, right? Let's say negative testing could be 1 plus 1 equals 0. All right, so this kind of test case should be as well, but instead of assert equal, we can use like assert false, that kind of thing. All right. Okay. Or I can give you this example. Okay. For the same login function, provide an incorrect password, and the system should also display an error message without crashing. Okay. Negative testing. Another negative testing could be the division. Anything, we cannot divide anything by 0, right? So the calculator application should handle this kind of exception condition here. Boundary testing. This is only for the when we want to test the some like when the input number is the range. Okay, let's say we want to test the letter grade. Okay, the letter grade of the your mark. Okay, and to see whether you will get the HDD pass credit whatsoever. So it has different range, right? From 0 to 100. You may want to test. Let's say for the HD, you want to test 80, whether 80 is HD or not, 100 is HD or not. Anything in between, we don't need to test because it is quite redundant. You know what I mean? You only want to test only the boundary of the class, that kind of thing, okay? We will talk about the boundary software testing later as well in the next few weeks. State-based testing, we want to test the state of the system. Let's think about, let's say state-based could be washing machine, right? Washing machine. It has a transition. It has a state. Okay, you start by putting the what's it like a washing liquid. You press the button. What is the next step? The drying. No, washing first. The washing cycle, and then the drying cycle, and then the washing machine stop. That kind of thing. Okay, so that's the state-based testing. Exploratory testing is like you just randomly come up with the test case. Okay, so it's not really systematic. That's the 5 common techniques to come up with the test case. Okay, but there are differences here, right? let me put this way. These are the 5 testing techniques, okay, in general. But let's give you a more example how to come up with the test case. I would say that the first thing first, once you understand the requirement, you need to come up with the test scenarios. It means that is the test description here, okay, the test scenario. It provides you a high-level description of what should be tested, okay? So it tells you the purpose, right? Let's say this is an example, okay? We want to test the login function. And the login function takes the username, which is an email address, and the password 4 digits, okay, for the login function. We know the requirement clearly here, okay? And if we need to come up with the possible test scenarios here, I would say that we can come up with 4 test scenarios, right? 4 combination. First, valid username, valid password, valid username, invalid password, invalid username, valid password, and the invalid username and the invalid password, okay? So these are the 4 scenarios. These are the possible scenarios that we need to cover systematically if we want to test the username and the password field here for the login function, all right? And once we come up with the 4 test scenarios, then we can derive or design the 4 test cases that belong to that test scenarios, right? Okay, so when we say valid username and the valid password, because the username should be the email address, I would just say aa@gmail.com, okay? And because of the password, the requirement here is that the 4 digits number, I would just say 1, 2, 3, 4. This is the valid username and the valid password. And for the other case, it's similar, right? I'll just do tweak some the test data here to make sure that they are aligned with the test scenarios that we design at the beginning, okay? Once we get the test scenarios, once we get the test cases, then we can write the as statement and then we are all done. We can execute the test case, okay? Another example, right? Let's say we want to test an e-health application for the, let's think about what is that? Like if you log into the MyGov, you see the My Health record, that kind of thing, right? Okay. So the goal here is that we want to test whether the patient record system, okay, is culturally sensitive to the needs and the preference of the indigenous people or not. And the requirement here is that when we talk about the patient demographic information, we need to collect whether the person is Aboriginal, whether the person is a Torres Strait Islander or not, or they are both, right? We want to make sure that our application is human-centric. It is culturally inclusive, that kind of thing, okay? So this is an example field that we need to test. When we know the requirement here, right? If you look at the figure on the bottom left, okay, is person of the Aboriginal or Torres Strait Islander origin or not, right? What are the possible options here? The person can only pick yes, I'm Aboriginal, or yes, I'm Torres Strait Islander, or I can pick both, right? I am both Aboriginal, I am both the Torres Strait Islander, or can just tick no, I'm none of these, right? These are the 4 positive test case scenario, okay? Makes sense? But what it won't work is that if I tick no and the yes Aboriginal, okay, this will not work at all because it's an invalid combination, right? So that's why we call it negative scenarios, the negative testing, okay? We also need to test it as well to make sure that the system can handle this kind of invalid input correctly, all right? Another combination, another incorrect combination, right? No and the yes Torres Strait Islander, and tick all of them. 3 options here. No and both Aboriginal and the Torres Strait Islander. Okay, make sense, everyone? Super clear? Okay, another example. Let me put this way. This is a gym eligibility. Let's say you go to the Monash gymnasium, okay, and the requirement here is that the gym is only valid for a person who is aged between 18 and 65. We don't want a person who is too young to go to the gym alone, and we don't want the person who is too old, okay, to go to the gym. We just want to mitigate the risk of having any injuries whatsoever. Okay, so that's the requirement. This function should return true if a person is aged between 18 to 65, otherwise false. So basically just return the Boolean values, either true or false. If we know the requirement here, right, this is the range, and then we can break the range into the 4 possible categories here. So that means we should test the age less than 0 as well. That's a negative scenarios, right? Because no one can be younger than 0. And then we need to test the value of the age between 0 and 18, okay? And it should return false because this person is ineligible, okay? And another test cases is that we need to test for the category for the person who is aged between 18 and 65, all right? And the senior person, okay? So that's the 4 test scenarios here. Invalid input here, age less than 5, okay? And positive scenario, too young, okay? 10 years old, 25, perfect, okay? 75, too senior. These are the 4 possible scenarios. And then you can come up with the test case here for that are aligned with your scenarios, and then you just execute the test case, okay? Right now, I'm just talking about how to design the test case. And then the next step, I'm going to talk about how to write the test case and implement the unit testing in the next few slides, okay? What do we mean by the good test case and or not so good test case or poor test case, okay? So the effective test case, it should be simple. It should be, you should keep the end user in mind. It should avoid repetition, right? For example, for the positive scenario, for the age between 18 and 65, the question is that, do we need to test every values between 18 to 65? Probably no, because it falls into the same categories, right? Otherwise, we would end up with 100 possible test cases here, which is quite redundant. It's not really effective at all. Let's say one test case execute 1 minute. You may need to execute how many? 100 minutes, right? Which is too long. Let's say, yeah, in modern software projects, we need to release tomorrow. We need to make sure that everything is efficient and effective. That's why we need to have the most effective test case design techniques to reduce the numbers of test cases into only a few of them. But we actually test everything, right? So we just test only 25, that which is a candidate belongs to the 18 for the third category here. Okay. So we should avoid repetition, avoid redundant test cases, that kind of thing. When we come up with the test case, we should not assume anything. Okay, it should not have any assumption. You want to try to ensure that you achieve 100% code coverage, that kind of thing. Okay, so I'm gonna the rest is fine. I'm gonna talk about that later. What is the code coverage? Okay. Now, before we move to the hands-on practice, I just want to check your knowledge a little bit, right? Okay, I have a question in the Zoom chat. What about the numbers 18 and 65? Shall we test them? It depends what kind of techniques that we apply here. Right now, when we come up with the test case, it's not systematic yet. It means that we just randomly pick up one value, right? But the ideal approach, if this is the range here, the technique that we need to apply is called boundary value testing, okay? So that means when we split the value into the categories here, we only want to test the boundary value, okay? So that means ideally we should test -1, 0, 17, 18, 65, 66. That's it, okay? This is the ideal value that we need to test for if we apply the boundary value analysis. I will talk about that in the next next week as well, which is part of the black box testing, okay? It's called boundary value analysis. Yep. All right. Okay. Go to the Flux. Yep. So everyone just go to flux.qa/mt8ng2. Okay. Yep. I'm gonna start the Flux quiz very soon. 1 second. Okay. I'm gonna turn off my share screen here and put it here. Yep. Okay. So based on the content, based on the lecture today, what is the test-driven development? Okay, first, writing test after writing code, writing the test before writing the code, writing the test during the code review. Oh, I should start the session, sorry. Writing tests randomly throughout the development process. Yeah, that's why I wonder that why there is no response here. Okay. Yep. Let me see if everyone can get the answer correctly or not, right? Yeah. Okay. Another questions in the Zoom. I think it means that you can come up with test cases first before development for CI/CD pipeline. Yes, definitely. So CI/CD pipeline is part of the pull request. That means for here, definitely yes. What I mean is that you should write the code. No, sorry, you should write the the test and then you write the code, test internally before submit the code or the code contribution, both of them to the pull request, right? What I mean is that if you rely on the CI/CD to automatically test your software system, it is really expensive because you make a risk like spending lots of effort, lots of resources on testing on the CI/CD server. But if you test internally on your local computer or laptop, right? So it's much more cheaper. Yep. So in short, what I mean is that testing on the CI/CD pipeline rely on that practice. It should be avoided. Okay, you should not like what you need to do is to test on your local machine first before test on the CI/CD server. Yep, 27 people have answered. Maybe I will pause and then I will review the answer here. Anyone is working on it? Yep, maybe I'll pause now and show the results, okay? In short, TDD, I emphasize several times already, we need to write the test case first before writing the code, okay? So what is the correct answer? B-boy. Okay, B-boy. Majority of the students get it right, okay? So the wording here for the answers is quite tricky, you know, before, after. So yep, try to pay a little bit more attention to the answers and then try to achieve 100% correct here. All right, next question. What is a unit testing? Okay, what it is? Is it a test case that check the entire application? Is it a test case that check the user interface functionality? Is it a test case that check the database integrity? Is it a test case that checks the individual units or components of the code? Yep, 24 now. Okay, maybe I will pause and then let's see the results. Yep, thank you, 100%. Wonderful. Well done, everyone. I'm so glad. Okay, and okay, this is the quiz for the next part. Now maybe I will move on to the ED STEM. Okay, the next part is that I'm gonna do some hands-on demo how to write the test case in the ED STEM. Okay, but before I do that, I will just give you the concept. Okay, what is the unit testing in Java? But anyway, if you want to follow the same demo here, I already implement this one for everyone. Okay, so you just go to the link in the slide here, and then you can access. Okay, but I'm gonna give you the lecture first. Okay, so when you write the unit testing in Java, normally we need to use the JUnit library. Okay, so the JUnit is the Java unit testing framework. It is an open source framework. So it provides lots of methods and library, the functions, everything to implement the unit testing here. And I'm gonna give you a high-level structure, high-level concept about the anatomy of the unit testing. Okay. first, what do you need to have is the method to be tested, right? Let's say this is a calculator class, calculator application. I have the 5 lines of code here, which is a calculator class. We have only one method, okay, which is the add, okay, public static int add, and it takes this method take 2 input argument, integer a and the integer b. Addition, nothing more than that. It should return a plus b, okay, simple like that. And once we have the method that we want to be test, we also need to write the test method, right? This is the test cases that is actually execute against that method to be tested, okay? So for the test method here, we need to import the JUnit classes or the packages, that kind of thing, okay? So this is the 4 import lines that you need to do, okay? It's classic, it's a standard. We can have more than this, but we cannot have less than this, okay? So once we import the JUnit libraries, then you need to create the test class, okay? Right now we call it calculator test, okay? And then because we create the class, how can we distinguish between the regular class and the test class? To do that, we need to have the test annotation, okay? To dictate whether each of the method below here is actually the test class or not, okay? So what you need to have is to have the test annotation at test, okay, in front of each of the test method, okay? Below here, we call the test method. Because Java is OOP, we need to test whether the class can be initialized correctly or not, right? So the first we need to test so we name it test init calculator class like this, okay? So basically we just create a new calculator class, calculator cal equal to the new calculator, okay? Parenthesis and the semicolon. That's how we initiate the class. Now, next, we want to write the test case, okay? We want to test whether the addition method here is actually functionally correct or not, okay? So we write another test method, okay? Add test again, and then void test add, okay? Bracket whatsoever. And then we write the assert statement, okay? Assert equal, as you remember, the assert equal, the first input parameter is the expected output, and on the right side, no, sorry. Yeah, so the assert equal, we want to test whether the output from the calculator.add here, okay, 1, 1 plus 1, it is equal to 2 or not, okay? Make sense? Yeah, this is how we write the assert statement. Once we write the assert statement in the EDStem, I already implement everything, okay? The next step is that you run the bash, run.sh, this one, the bash script to execute the JUnit in the EDStem terminal. Once you get the result here, okay, the output, it will tell you how many test cases that have been found, okay? So it found 2 test cases here, okay? Test init calculator and the test add. And then it tells you whether the test method are successfully executed or not, okay? And then it tells you how many test methods are failed to execute. Right now it's failed because I write everything correctly, okay? And then you can check the code coverage as well. It means that how many, based on the 2 test cases here, it covers how many lines in the method to be tested, okay? So because right now we have how many lines? 5 lines, 5 lines, okay? So it tells you the JACO coverage report, right? It tells you there are 5 lines, and then whether is there any lines that are missed or not, okay? Right now it is 0. Okay, now I'm gonna show you the real one. Yep, what do we do? Okay, so everyone, if you go to the EDStem, right? This is a unit testing in Java. I provide the instruction very clear on how to write the unit testing. The first thing, as I tell you before, okay, we need to implement the test case because this is a calculator class and we have the addition method here. So we just write the test case based on what we expect, right? When test init calculator, okay, calculator cal equal to now new calculator, okay, this is what we expect, okay, and then add, we need to say that assert equal, okay, equals, okay, what is that? the expected output, right? So we're gonna call what is that? What it should be, calculator, okay? Calculator dot add 1 plus 1, it should equal 2. And if we follow the TDD practices, because we write the test case, but we haven't write the code yet, it should fail. Make sense? So let's go to the EDSTEM terminal, click the activate here, and then what I tell you before is that you run bash run.sh, okay, like this, enter. You see, something is wrong, okay? But this is not the test fail. I implement it wrong, okay? What I miss here, the semicolon, okay? Okay, let me run again. Bash run.sh. Oh my goodness. Something is error again. Okay, what is that? Java 4 missing the return statement. That's right, okay? So it tells you that there is an error on the calculator.java here, right? Because the test case try to execute the calculator.java here, but there's nothing returned, right? Missing the return statement is wrong, okay? Let's say if I return 0, which is wrong again, okay? Run the JUnit again, okay? It has the return statement already, but it tells you that there are 2 test cases. Is that right? Okay, and 2 test cases can be start, okay, but one is successful, one is fail, okay. What it means is that this one we can initialize the calculator class definitely, but the addition is fail. Make sense? Because 1 plus 1 it doesn't return 2, but it returns 0. Now I'm gonna implement it correctly, okay? But let's say that if I don't, and let's assume that I am very new to Java, I have no idea what's wrong, right? So we can look at the coverage report as well, so to identify what went wrong, okay? To do so, you click here, follow the instruction, okay, to open the coverage report. Sorry. You click here, okay? Click here, you go to the report, click the report, open the report, go to the index, right click, open in the web preview, and then it tells you this is a Jacoco coverage report, right? It has 5 lines, but 1 line is missing, something is wrong. And then I don't know, I just want to find out, right? This is how we debug it. So test as is not covered, this is wrong. The test as is incorrect, this test case is failed. Now I'm gonna make it pass, okay, based on the TDD. Okay, A, it should be in A plus B, okay, all right. And then I run the bash run.sh again, okay. So 2 tests is successful now, and 0 test is failed, okay. Everything is correct in order. Go to the coverage report, preview, okay. And right now I achieve 100% code coverage, right? Okay, next, the calculator class, we cannot have just the addition method alone, but we need to have the subtraction, multiplication, and the division as well. Make sense? Let's say if I implement more, right? Again, I'm gonna do the follow the TDD practices, okay? So I'm gonna write the test subtraction, and let's say I assume that we're gonna call the method subtract. 1 minus 1, it should equal 0, all right? And multiply, okay? Maybe I'll just keep it short, subtract, multiply, and multiply. 2 multiplied by 2 should equal 4, okay? Yep. And another one, the division, okay? Division, okay? So 2 divided by 2, how many? 1. Is that correct? Okay, all right, let's see. Yep, bash run. Yep, bash run.sh. Oh no. Okay, now what do we expect here? We expect to have 5 test cases, right? The class and the 4 method here, but it should pass only 2. The other 3 should be failed because we cannot call that method. We haven't implemented yet, and actually everything is failed. To be honest, we cannot even execute it, right? Yeah, because the tree method here, we cannot execute it. Okay. So yeah, cannot find the symbol. Now we're gonna implement it. This is what we expect. Okay. I'm gonna repeat. Okay. Was that fun, everyone? Subtract. Okay. Multiply. Dy. All right. So a minus b, a multiplied by b, and a divided by b. All right. Bash run. Something is wrong. What is wrong? In dot division, calculator symbol. Yep. Division. Thank you. See. Yep. Very good. Okay. And run again. Here we go. This is what we expect, right? 5 test cases. 5 test cases are successfully run and 0 test is failed. Is this the best test case that we can design? What do you think? Is there anything wrong with the calculator application here? Calculator class? Anything that we are missing? Anyone knows? Let me know in the Zoom chat interface. No, that's too far. Okay. What I mean is that when we do the division, okay, we need to go back to the mathematics background. We cannot divide anything by 0. Is that right? So we may need to handle the 0 case, throw the exception or whatsoever as well. Okay. What should we do here? Maybe we need to, it depends on the requirement. Okay. So, but what I mean is that we need to test the divide by 0 as well. Okay. All right. Move back to here. What I'm missing or not, right? What else? Let me think. Report. If we check the report again, it should achieve 100% code coverage anyway because everything is covered. All right. One more thing that I want to tell you here is that, let me see. If you go back to the programming competition, right? You write the test, you write the code, you submit the code to the online judge or that kind of thing. It will tell you whether your code is implemented correctly or not. In the same way of practice, okay, in the same style, I also implement the mark, okay, button here. If you click the mark button, right? Okay, it will tell you, okay, something is wrong. Let me put this way. And I need to fix the bugs on the fly, okay. Okay. Yep. So what I mean is that, one second. Yep. This is too real, okay. Okay, so right now, what I mean is that when you implement the code correctly, you test the code already, you may want to assume that your code is functionally correct, right? But to test it right now, you can click the mark button to check whether your code is implemented correctly or not. So what we have here, it will tell you, it will automatically provide the feedback to your submission, okay? Whether I need the class correctly or not, you test the addition function correctly or not, you do test the subtraction correctly or not, multiply correctly or not, and the division correctly or not. And whether you test your own code, okay, write the test case and achieve 100% code coverage or not, right? Okay, so it, right, for this one, it has 11 points, okay? Let's assume that you believe that, okay, you implement the code correctly, okay? It return A, okay? And the test case here, it also return A, okay? Return 1, okay? When you run the code here, right? Bash run.sh, okay? you may get the 5 test case successful and 0 fail as well. So what it means is that you test case, okay, testing only showed the presence of the bug but not their absence. Okay, right now you test everything, there is no bug detect here, but it doesn't mean that there's no bug at all. Okay, so the test cases part, it could mean that your test case is wrong to the code as well. Do you know what I mean? But when you click the mark button here, it will tell you that your addition function is incorrect. Do you know what I mean? So what I mean is that when you do the assessment for, right, you need to write the code that is functionally correct, write the test case to achieve 100% code coverage in order to achieve the full mark. Okay. If you do any sum of this, you won't get the full mark. Okay. And like in this example, you write the code, you achieve 100% code coverage, but it doesn't mean that your code is actually correct because your code is wrong. It doesn't pass our hidden test cases here. Okay. So you need to fix to make sure that everything is correct in order, to pass everything. Okay. Yep. So with this approach, okay, you will get the immediate feedback to help your learning the unit testing as well. Okay. Any other questions so far? Yeah. About the unit testing in Java? No. Okay. So I'm gonna move on. Now that part is Java. Okay. So after I do this demo, I highly encourage everyone to practice by yourself as well. Okay, the content is in the week 7 lecture here. Okay, you can access for one for the Java and another one for the Python. Now I'm gonna do the demo for the Python. Okay, so for the Python, what is the unit testing in Python? Right, we need to use the PyUnit library. So PyUnit library, it is a unit testing framework in Python, or it called unit test as well. It provides lots of features like the test feature, test discovery, test suite, as a statement whatsoever. It's the same as the Java one, okay? But the interesting part is that for the Java, we need to have the test annotation at test, okay? But for the Python, we only need to name the test method, start with the test underscore. That's it, nothing more than that, okay? And then the testing framework will automatically detect and execute that test method, okay? I'll try to mitigate follow the same style, okay? The anatomy of the PyUnit test case is that first you need to have the method to be test and the test method, the same one, okay? For the method to be test, let's say we implement the Python class here, calculator init, okay? And then we have the add, because we want to make sure that add is part of the calculator class, so we add self here as well, okay, as a member of the calculator class. For the test method here, we need to import the unit test library. So first we import the calculator file, import the unit testing, okay, and then we create the test class here, test calculator, and then we inherit the unit test.test case class, okay. First, the first test method here is that we need to test the init calculator. So calculator equal to the calculator bracket, no semicolon, okay, in Python. And then we create a test method, okay, test add, okay. To test this one, because add is part of the calculator class, we need to init the class first, okay. Calculator equal to calculator, result equal to calculator.add, 1 plus 2, it should equal 3, okay. So because this is Python and we do the class inheritance here, so we need to write self.assert equal and then result expected outcome equal to the 3, okay. No, sorry, result is the actual output and 3 is the expected output, okay. Just want to make it clear. And then once you do that, right, you can execute the test file by Python test calculator, or you can press the run button here. I already config everything for you, okay. You just click the run button and then you get the coverage percentage. it tells you, okay, how many lines, how many statements are in each file, and how many lines are missed, okay, 3 lines. What is the coverage percentage here? 73%. It means that the test case that we implement, that we executed, only covers 73% of the lines of code in the calculator.py, okay? And it tells you what lines are missing. The line number 9, line number 12, and line number 15, okay? Now, I'm gonna do the real demo here, okay? So first, what do we need to do? Let's say, yep, this is the fresh scaffold that you will access from the EDSTEM, okay? Unit testing in Python. At the beginning, there's no test case, there's nothing, but at least I give you the high level structure already. So you can continue, only focus on writing the test case, okay? So to test the calculator application, we need to test whether the calculator class can be init or not, right? So what we will do is that we write the calculator equal to calculator like this, okay? And then for the addition test, the addition part, calculator, okay, equal to calculator, yep. And then resolve. This is the expected, no, the actual output, right? Calculator dot add 1 plus 1 equal, yep, and self dot assert equal, okay. As you can see, it will tell you what is that, this is like the documentation, the guideline, what is expected, okay. Equal, we expect the result to be 3, all right, with the message. This is just a message. 1 plus 1 should equal 2. Sorry, it should be 2. Yep. And then if we execute the test case, let's say run here. All right. What's wrong? Okay. There's a bug. There's a bug. Okay. Don't worry. Scaffold. Where is the scaffold here? It should be test. Yep. Again. Run. Okay. So now you write the test case, right? And I told you that you can execute the test file with this command as well. So I'm going to try and tell you how does it look like, okay? So once you write the test case, you go to the terminal, activate the terminal. You can run like this, okay? Sorry. It should be Python, okay? Now it tells you that add here, okay, we haven't implemented yet, so it is incorrect, right? So we're gonna implement it, okay, to make it pass, all right? So what it should be return a plus b, and calculator, we don't need anything. I'm gonna execute this one again, okay? All right, what's wrong with my code? Now I'm gonna debug like on the fly. Okay. Okay, I got it now. It should be self like this because it is a member of the the class. Okay, so it should be like this. Yep. Try again. Yep. Okay, it works now. Oh, nearly there. All right. So now you have the test case here, the test method. You already test the class. You have test the addition function. Okay. Now, because this is a member of the Python class, you need to create the calculator class, run execute the add method here. 1 plus 1 it should equal 2. All right. You already implement the code here. You execute the test case. When it says ... it means that the 2 test cases are executed correctly. Okay. Let's say that if I make the test case in, let's say if I make the code incorrect, okay, return a minus b. A minus B. Intentionally, it will show that the test case is failed. Sorry, I need to click this one. See, the test case is failed. One is passed, but another one is failed. F is failed. So it will throw the errors in the terminal that throw the assertion error, right? The result here, we expect 2 because 1 plus 1 should equal 2, but right now what we get is 0 because it is A minus B, and 1 minus 1 equals 0, which is not 2. Okay, so my code is incorrect. That's why we need to fix my code to make it correct. Okay, to debug, you just go to the that test calculator.py line 11. This one is failed. Then you can go back to the addition method, right, to make it pass. Okay, when you write the test case, how do you know that the test case is effective, right? So you need to check the code coverage. How many lines in the file that are executed by the test cases, okay? So if you run here, right now, the output is the same, okay? You have 11 statement here, okay? 11 statement, you remove the blank line, okay? We only focus on the actual lines of code. It missed 3 lines because the line number 9, okay, number 12, and number 15, we haven't write the code, and we haven't write the test case yet. Make sense, everyone? Okay, so that's why it have not been executed. But what if I remove this one? I should get how many code coverage that I should get? Can someone write in the Zoom chat? Hello. One answer. If I execute, what is the code coverage that I will get? Yeah. Any volunteer? No one? Really? It should be 100%, right? Yeah, so if I click here, it should be 100% because we test we have the add function, and we test only the add function here. Everything is 100, okay? But because the calculator class here, we have subtract, multiply, and the divide. If we click the run button, okay, we haven't got anything covered for the line number 9, 12, and the 15. So what we need to do, okay, we need to extend the test case, okay, no, sorry, extend the test case and extend the code to achieve 100% code coverage, okay. What I will do is that for the subtract, right, write the code here, okay, A minus B, multiply, return A multiplied by B, divide numerator, divide by the denominator, all right. And if I run the test case, okay, everything is the same. We write the code, everything is correct, but we haven't write the test case yet, so we cannot achieve 100% code coverage. So we need to write another 3 test cases, okay. Test subtract, all right. Multiply, yeah, 1 minus 1, it should be 0, okay. 1 multiplied by 1 should be 1, okay. Multiply, yep. If I run like this, what is the code coverage that I will get? 91%. There is one line that is missing, which is line 15, because I haven't implemented the test case for the divide yet. Make sense? Divide. Divide. 1 divided by 1, it should return 1. Yep. And then if I run again, what's wrong? Indentation. Okay, something is wrong with the indentation. Okay. All right, now I get 100% code coverage. Okay, so that means I implement the code correctly, and I implement the test case effectively as well, because I can achieve 100% code coverage. Now the next step is that once you are ready to, you are confident that your code is correct, your test case is the best, then you can click the mark button here to check whether everything is correct or not, right? And it tells you that, hey, look, you achieve 100% code coverage. You init the class correctly. You implement the add function correctly. You implement the subtraction correctly, multiply correctly, and the divide correctly. What if I miss one of them? Okay. What if I miss one of them? What is that? Let's say I remove the test case for the divide. Okay. I remove the code for the divide and remove the test case for the divide. I still get 100% code coverage, right? But the instruction here is that we ask everyone to implement the four function, okay? The four function here: subtraction, multiplication, and the division. If you submit the mark button, you achieve everything except the divide because you haven't implemented the divide yet. So the purpose of the assessment for what we would like to objectively assess is that you implement the code correctly, functionality correctness, highly achieve code coverage as well, okay, and completeness as well. Yeah, functionality completeness. Okay, that's all for today. Any questions so far? Yes. How many times are we allowed to hit mark? Okay. What I would like to tell you is that the instruction for the assessment for it is underway, and then we will let you know in the next few weeks as well. Okay. But what I mean is that in the next 3 weeks, everyone will have a chance to practice. I create 9 exercises already for everyone. For example, in this week, in the apply session, okay, everyone will work on the 3 unit testing exercise here. First, this is the one that I cover in the lecture. Try to work by yourself, complete it, and then you can practice the gym eligibility as well. That's another practice, okay? So this is the requirement. You write the code, you write the test case. Same to the withdrawal money as well. These 3 exercises are very simple, very easy. Once you go through it, you will be able to work on the assessment for. I also have another 6 exercises for the week 8 and the week 9 as well. So don't worry, you will have in total 9 exercises to practice before you work on the real assessment for. Yep. Yep. So next, in the next few slides, what I want to cover is that similar to the Java unit testing, right? There are different types of the assertion as well. Okay. What we have covered in the lecture here is that assert equal. A equal to B or not. This is what we want to check, whether the actual output is the same as the expected output or not. Okay, A equal to B. Assert not equal, assert true. Assert true, it means that whether X is returned true or not. Okay, assert is not. Probably this is like for the list in the Python. Maybe it's a bit too advanced for some of you. Don't worry. But I think the 4 common options here that probably everyone may want to use is the assert equal, assert not equal, assert true, and the assert false. All right. Okay. What else? Yep. Code coverage. This is just a follow-up lecture as well. So I have presented to you before that when you click the run button or that kind of thing, it will tell you whether your test case is effective or not. So code coverage is one of the measure to measure whether your test case are effective or not. Ideal test case, it should cover every line of code, right? This is what I mean is that you want to make sure that every line of code are executed by the test case because you have already tested what are expected to be. You want to test the expected behaviors of all of the functions. Okay, so that's the code coverage. In the future, probably week 9, I will talk in more detail as well that there are different types of the code coverage. How can we design the test cases to achieve 100% of different types of the code coverage here? In short, what we are focusing on today is called statement coverage or line coverage. Okay, how many lines are executed? Okay, this is the common approach function approach, function coverage is like the completeness, whether your test case actually cover or execute all of the functions or not. Branch coverage, this is for like a if else condition. Let's say when you have if a equal to true, it should do like this. If else, and it should be like this. If that means the test case should cover both if true and if else, okay, both cases, then you can get 100% branch coverage. Okay. So yep, in summary, okay, today we have talked about the test-driven development, unit testing, and the code coverage. I also have run some run the hands-on demo about the unit testing in Java, about the unit testing in Python, how to test your first calculator class. And if you have any feedback, please provide your response to the ED-STEM as well. And before we finish, I would like to have some of the Flux questions as well to test your knowledge. All right. Okay, start. Yep. So everyone, please go to flux.qa/mt8ng2 again. Okay. Yep. So the question is that what annotation is used to mark a method as a test method in the JUnit? Yep. Okay, right now we have 19 people have answered. And by the way, I just really want to thank for your active participation as well. I'm so glad to see everyone is very active. And if you have any questions, please feel free to write in the Zoom chat. I will try to cover and answer as much as possible as well. Okay, right now we have got 22 people answer. I'm gonna pause the quiz and then review the answer now. So in short, I think for this one, it's very easy, right? It should be at test, the first one anyway, okay? That's the test annotation for the JUnit. At least 82% of the student here got the answer correctly. Very well done. If I go back to the unit testing in Java here, this is a test annotation, okay? At test, we write the test annotation before the test method in order to indicate that this method is the test case, okay? Nothing more than that. This is how we write the test case in Java. All right, next, okay? What is not a good characteristics of which of the following is not a characteristics of a good unit test? Which one? Is not, again, okay, read the question correctly. Which one is not a good characteristic, okay? It's not a characteristics of a good unit test. Yeah. All right, we have a few students. No, not a few, I mean a bunch. 21 people have answered already. I'm gonna pause the quiz and then I'm gonna review the answer now. Yes, that's right. It tests multiple functionalities at once. Yeah. So as I have mentioned before, that this is the characteristics of the good test case, right? Ideal one, we should write a few numbers of test cases, minimize the test to maximize the code coverage. This is the ideal approach, all right? The most effective one. And what we should avoid is to avoid the repetition, and we should avoid the, we should make sure that they are independent, okay? The test case should be independent. It should not test multiple functionalities at once. Otherwise, it does not serve the one purpose, and it's not simple enough. Simple test case, it means that it should be understandable by itself. All right, when I design the test case for the addition, I never say use like 1 million plus 1 million, you know, that's way too complex. Just test, just like use only the simple input data. That's how we want to test, right? Make sense, everyone? Yeah. Yeah. And all right. Which of the following assertions is an example of a positive test case for a function that calculates the sum of two numbers? Okay. So we talk about different types of the test cases before. The positive testing, negative positive test case, negative test case, boundary test case, state-based test case, exploratory test case. So here, which one, okay, is the positive test case for a function that calculates the sum of the two numbers? Okay. I understand that the concept about unit testing is very challenging and it's not easy to understand at all, and it's quite new to most of the students as well. What we have achieved today, I think I'm quite happy. At least more than 80% of the students understand the concept of the software testing, understand how to implement the unit testing correctly, right? So 25 people have answered. I'm going to pause the quiz and review the answer now. Okay, so what should be the answer? Should be C. Okay, C. That's a positive test case. Look at that. Okay, well done. 100% correct. That's how I feel. Thank you. Okay, next. What about the next question here? Okay, I'm gonna start. Yep. Which of the following assertions is an example of a negative test case for a function that calculates the subtraction of two numbers? Okay, negative test case. I'm so glad because right now you can design different types of the test case now. When we test the addition, it's not just only 1 + 1 = 2, but now you can decide the negative test case as well. You check whether the input is valid or invalid. You know, you can come up with different scenarios. Now, when you have multiple test cases, multiple scenarios, right? The functional, it tend to increase the quality of the code. Make sure that the functionality of the code is also correct as well. That's really absolutely perfect. Okay, well done, everyone. Okay, negative. What does it mean, negative here? Okay, negative test case. I'm not going to say anything until everyone have answer. Okay, in the quiz. All right, I'm gonna pause the quiz now in 5, 4, 3, 2, 1. Okay, so what is the answer here? 1 - 1 = 0. That's a positive test case. 10 - 5 = 5, 5. Yeah, so it should be C again. Okay, should be C again. And everyone got it correctly. Okay, well done. Yep, most of the students got it correctly. Yep, 5 - 5, it should equal 0, right? But now the expected outcome is 10, which is wrong. Okay, so this is wrong. All right. So the final question here, what do you think about the today hands-on demonstration on the unit testing? Would that be helpful or not? Just want to hear from everyone so I can improve my teaching practice in the future as well. You know, so what you have to do, what you have learned today is, again, test-driven development. We talk about the unit testing, how to implement the unit testing in both Java and the Python, and the assessment for. We also create the both version as well, which have roughly this roughly similar difficulties. Okay. Yep. Okay. Beautiful. I think I'm gonna pause the quiz now, and yep, let's see the result. Okay, very good, thank you. Okay, I found that we found that most of the students are quite enjoy with the lecture, and they find the today demo is quite helpful as well. And again, just want to emphasize that if you have any questions or concern, please feel free to let us know anonymously as well. This is an anonymous feedback. Tell me, let us know how do you feel about today's lecture and how can we improve it next time. Yep, I think I have covered everything. Yeah, any other questions from the Zoom? Do we need to catch an exception for invalid input like divide by 0 when testing? Yes, yeah. Ideally, yes, we should do that. Yep. So I think this one, it depends on the requirement, what the output should be, right? Yep. Mm-hmm. Yeah. Any other questions? A good calculator application, it should tell the, it should shows the error message when the input is invalid, right? It should not show like a bar to the end users at all. Mm-hmm. Yeah. Okay, all right. Sounds like everyone enjoyed with the lecture today so far. When we do negative, okay, one last question. You don't let me go. When we do negative testing, how does the correctness be marked since the inputs are wrong? Okay, I think it depends on the requirement again. Ideally, we should tell you if the input is invalid, what the error message should be and how the function should return the value. You know what I mean? Instead of return true or return false or return the number, maybe the requirement may say that, okay, it should return invalid, something like that. For the division or the calculator, that one, I will improve after the lecture as well to make it clear. All right. Mm-hmm. Yeah. Mm-hmm. Okay, all right. Thank you so much. And just want to emphasize again today, no, sorry, this week has the deadline for the assessment too. And in the today, no, sorry, this week apply sessions, we will practice more on the unit testing as well. And you can use the knowledge for your assessment 3 and the assessment 4 as well. Okay, so see you everyone in the today apply sessions. Bye-bye.